The same storm system that will be spinning up severe thunderstorms and hail across the Nebraska sandhills and western South Dakota this afternoon is also going to be dragging a cold, dense dome of Canadian air far enough south to dust the mountain peaks of New Hampshire and Maine with snow tonight and into Saturday morning. On one side of this country, supercells are loading. On the other, it is going to feel like the third week of November. We have a genuinely strange atmosphere to break down today, and the details are going to matter a great deal depending on where you live. Welcome to Sky Space Lab. I am Arthur. This channel is very new, and every like and subscription truly helps us grow and bring you even deeper, more powerful research. Thank you in advance for every like and follow. Right now we're dealing with a weather pattern that is, by any reasonable standard of late May meteorology, bizarre. The jet stream, which is the river of fast-moving air high up in the atmosphere that essentially steers our storm systems and determines who gets severe weather and who gets sunshine, is not doing what it normally does this time of year. Instead of taking a relatively flat west-to-east path across the United States and funneling moisture and energy into the central and southern plains the way it typically does during the peak of severe weather season, it has contorted itself into something meteorologists call an omega block. That name comes from the shape the pattern makes when you look at it on a map of upper-level winds. It resembles the Greek letter omega. Two low-pressure systems, one anchored along the west coast and one sitting over eastern Canada, are essentially sandwiching a powerful ridge of high pressure that has built up over the central and northern plains and extends deep into Canada. What this configuration does to our weather is significant in several ways. First, it prevents storm systems from sweeping cleanly across the country the way they do during classic outbreak setups. The ridge acts like a wall. Energy gets deflected around the edges of it, rather than punching through the middle. That is why, for most of this final week of May, we have not seen the kind of organized, multi-state severe weather outbreaks that people associate with this time of year. Instead, we have been watching a parade of smaller, messier, harder to predict mesoscale severe weather events firing along the edges of this pattern, particularly across the southern plains and the Tennessee Valley. Mesoscale means small scale, and that is exactly the nature of the threat we have been dealing with and will continue to deal with over the next several days. Second, this omega block is allowing an unusually deep plunge of cold Canadian air to pour down the eastern flank of the pattern and settle over New England. That is not something you would normally forecast for the last weekend of May. Temperatures across much of northern New England heading into tonight and Saturday morning are going to run as much as 20 to 25 degrees, below average for this time of year according to the National Weather Service. In places like Berlin and Lincoln, New Hampshire, that translates to readings that will drop into the mid-30s by Saturday morning. The atmosphere above the region is going to be cold enough to support snow down to elevations of 4,000 to 5,000 feet, based on atmospheric temperature profiles, which means every mountain peak in the White Mountains of New Hampshire and the Western Mountains of Maine is going to be in the snow zone tonight. Third, the ridge is not going anywhere quickly. The storm prediction. Center's Day 4 through 8 forecast discussion, issued Friday morning, notes that a shortwave trough, which is a smaller disturbance embedded within the larger flow, will rotate slowly eastward from the northern Rockies into the northern plains through early next week. The ridge itself will shift gradually eastward, moving from the north-central United States toward the Great Lakes by roughly Wednesday. That means the omega block will be slowly breaking down, but it is not collapsing all at once, and the character of the severe weather threat will be evolving day by day in ways that require careful attention. As we move into the first week of June, the door begins to open again for more organized, large-scale severe weather across the plains, but we're not there yet. Now let us get into the specific threats over the next couple of days, because there are details here that are genuinely important if you live across a wide swath of the central United States. For tonight, which is the overnight period running from now through Saturday morning, the Storm Prediction Center has a slight risk of severe thunderstorms, which is a level 2 out of 5, in place for a corridor stretching from western and central Nebraska up into southwestern South Dakota. A marginal risk, which is level 1 out of 5, extends across a broader area covering the northern high plains to the north and the central plains and southern high plains to the south. The primary hazards tonight are large hail and damaging wind gusts. Here is what is driving this setup. A mid-level shortwave trough, that smaller disturbance I mentioned a moment ago, is rotating out of the Rockies and pushing into the central plains this afternoon and evening. As it does, it is triggering the development of a surface low-pressure system across western Kansas. That surface low is going to drive a dry line, which is a boundary between dry continental air from the desert southwest and more moist air coming up out of the Gulf of Mexico, northward through the region. A dry line is one of the most reliable triggers for severe thunderstorm development anywhere on Earth, and during the peak of severe weather season in the Great Plains, a strong dry line in the right environment can set off discrete supercells capable of producing very large hail and violent tornadoes. The Storm Prediction Center notes that in the most favored zone, which is from the Nebraska Panhandle northwestward into southwestern South Dakota, the combination of mid-level forcing and a dry line boundary should allow storms to fire by mid-afternoon, with peak activity likely during the late afternoon and early evening hours. The primary concern with these storms is going to be large hail and severe wind gusts. There is a 2% tornado probability outlined for the region, which reflects a real but conditional tornado threat. The SPC notes that some model guidance, if it verifies, would support a more notable tornado threat across this corridor, but that scenario requires the moisture transport to trend a bit more favourable than the current consensus. The guidance consensus right now is keeping tornado probabilities modest, not because the wind shear is absent, but because the low-level moisture depth is uncertain. What that means in plain terms is this: we need dew points, which is a measure of how much moisture is in the low levels of the atmosphere, to be in the lower 60s or higher to really charge this environment for tornadoes. Right now, there is some uncertainty about whether moisture will mix out ahead of the dry line during the afternoon heating cycle, which would knock those dew points down and reduce the overall threat. If the moisture stays deeper and the storms can remain discrete, meaning individual rotating supercells rather than a messy cluster, there is definitely a ceiling here for a stronger tornado threat. But if the atmosphere mixes out more than forecast, or if storms upscale quickly into a squall line, the tornado threat diminishes considerably, and we are looking mostly at wind and hail. That conditional nature is exactly why the SPC has this at a 2% tornado probability right now rather than a higher number. For those of you in the slight risk area, which again covers parts of western and central Nebraska and southwestern South Dakota, storms are expected to develop by roughly 2 to 3 in the afternoon and will be capable of producing large hail, possibly reaching golf ball to tennis ball size in the most intense cells. The SPC discussion specifically mentions that mid-level flow between 30 and 40 knots is expected across this region, which is enough to support supercell structure. That is the kind of storm organization that can produce baseball-sized hail, and, if the low-level wind profile cooperates, brief tornadoes. Make sure you have a way to receive weather alerts in real time tonight if you live in western Nebraska, the Nebraska Panhandle, or southwestern South Dakota. Do not get caught off guard just because this is a conditional setup. Conditional does not mean impossible. Further south, isolated storm development is possible along the dry line stretching from West Texas up through central Kansas through the afternoon, but the Storm Prediction Center notes that upper-level forcing will be focused farther north across this southern portion of the dry line, and the low-level moisture is forecast to mix out ahead of the boundary through the heat of the day. Despite these limiting factors, strong surface heating will leave the atmosphere mostly uncapped, meaning storms can pop up with relatively little trigger needed. A supercell or two is possible from central Kansas southward, through the Texas Panhandle, and into West Texas, but the severe threat with these storms is expected to be more isolated than the main action further north. The main hazards from any storms that do fire from southern Kansas through West Texas will be damaging wind gusts and large hail. The tornado threat in this southern corridor is low. Meanwhile, across Montana, isolated to widely scattered thunderstorms are continuing to develop within the higher terrain as the shortwave energy pushes through. The SPC's overnight discussion notes that these storms are moving very slowly due to weak mid-level winds, and while occasional intensification to severe limits is possible with the deeper storm cores, overall organization is poor. The primary threat across north-central Montana will be large hail and a brief severe wind gust with any storm that can tap into stronger flow above 5 kilometers altitude. This threat diminishes through the late evening hours. Now I want to spend some real time on the situation in New England tonight and tomorrow morning, because what is setting up across that region is genuinely unusual, and the combination of hazards it is going to produce deserves a thorough explanation. The same omega block pattern that is suppressing major severe weather across the central United States is directing a powerful low-pressure system out of eastern Canada down toward New England. This low is going to be positioned just offshore of the New England coast by early Saturday morning. The National Weather Service and CBS Boston's meteorological team have both highlighted that atmospheric temperatures will be cold enough to support snow down to roughly 4,000 to 5,000 feet above sea level across northern New England tonight through Saturday morning. Below that elevation, temperatures will remain just above freezing, meaning the snow will melt to rain before reaching lower elevation communities. But above that threshold, every mountain top in the White Mountains of New Hampshire, including Mount Washington, and the highest ridges of western Maine, including Sugarloaf Mountain, are going to be in what meteorologists call the snow zone. The National Weather Service is currently expecting snowfall totals of roughly 1 to 3 inches at the mountain summits, with some locally higher amounts of 3 to 6 inches possible at the highest elevations. CBS Boston reported that the jet stream has bent into the Omega block configuration that is allowing this cold air to plunge southward, and with atmospheric temperatures dropping cold enough for snow above 4,000 feet, the timing for mountain snow in New Hampshire and Maine runs from tonight through early Saturday morning. This is not a winter storm. It is not going to be buried under a foot of snow, but for the last weekend of May, getting 1 to 6 inches on the highest peaks of the northeast is legitimately unusual. Mount Washington averages more than a foot of snow during the entire month of May over its climatological record. But snow at the end of May rather than earlier in the month is still notable, and what makes this particular event worth watching is the combination of factors producing it. Below the summits, temperatures across Boston and southern New England will be running 20 to 25 degrees below average on Saturday morning. Wind chills across the region are going to be extremely unpleasant for late May, with gusty northwesterly winds flowing around the backside of that offshore low-pressure system. If you have outdoor plans in Boston, Providence, Portland, or Manchester this Saturday morning, dress for mid-November, not the beginning of June. Temperature recovery during the afternoon will be limited because cloud cover and persistent northwesterly flow will keep the cold air locked in place through much of the day. The broader question this raises is how quickly this Omega block breaks down, because the cold air mass it is delivering to the northeast, and the implications of that for the early days of June are significant. The Climate Prediction Center's 6 to 10 day outlook is signalling above normal probability for below average temperatures across a broad swath of the eastern United States extending into the southern plains. That is a signal that the cold air influence from this Omega block pattern will continue to suppress temperatures well into the first week of June across the east. What happens from the other side of the country is where the severe weather story for the next 7 to 14 days begins to come into focus. The mid-level ridge, according to the Storm Prediction Center's Day 4 through 8 discussion, is forecast to migrate eastward from the north-central United States toward the Great Lakes by roughly Wednesday of next week. As that ridge shifts east, a shortwave trough will be advancing slowly from the northern Rockies into the northern plains behind it. That combination, a ridge moving out of the way and a shortwave trough rotating in from the west, is the classic sequence that reloads the central plains with severe weather potential. The question every forecaster is asking right now is how organised that process will be, and whether a more substantial low-pressure system will eject out of the West Coast trough and ride across the Rockies into the plains during the second week of June. The European Centre for Medium-Range Weather Forecasts, commonly called the European Model, has been hinting at exactly that scenario, while the American GFS model is somewhat slower and less aggressive with the timing. That disagreement between the two models is important context for understanding how confident we can be about the extended outlook, and we will get into that in detail shortly. But first, let us walk through the peak severe weather window for this weekend in the kind of hour-by-hour detail that actually helps you plan, because Saturday is the day that deserves the most attention of anyone living from the Nebraska sandhills southward through West Texas. The storm timeline on Saturday begins in earnest across the Nebraska Panhandle and southwestern South Dakota during the early to mid-afternoon hours. By roughly 1 to 2 in the afternoon local time, the shortwave trough will have moved far enough northeast to start eroding convective inhibition across the region. Convective inhibition is essentially a cap in the atmosphere, a layer of warmer air aloft that acts like a lid on a pressure cooker and prevents storms from firing until conditions are just right. When the cap erodes, storms can explode rapidly. The first echoes on radar across the Nebraska Panhandle are likely going to appear between 2 and 3 in the afternoon, initially as isolated cells along the dryline before some of them develop supercell characteristics. A supercell is a rotating thunderstorm. It is organized around a persistent rotating updraft called a mesocyclone, and it is the storm mode most capable of producing significant tornadoes, very large hail, and destructive straight-line winds. The Storm Prediction Center notes in its Saturday Outlook discussion that 30 to 40 knots of mid-level flow will be in place across the region, which is sufficient to support supercell structure. The critical variable, as I mentioned earlier, is the low-level moisture. If dew points in the Nebraska Panhandle and southwestern South Dakota can hold in the lower 60s through the afternoon heating cycle rather than mixing out, the environment becomes meaningfully more favorable for tornadoes. Storm chasers and meteorologists are going to be watching that moisture depth very carefully through the morning hours on Saturday. By about 3 to 4 in the afternoon, storm coverage should be increasing across western Nebraska and into the Sandhills. This is the window where, if we do end up with discrete supercells rather than a cluster, the hail threat becomes most significant. Golf ball to tennis ball sized hail, roughly 1.5 to 2.5 inches in diameter, is within the range of what the most intense storms could produce during this time window. Protect vehicles if you live anywhere from Scottsbluff and Alliance northeastward through the Sandhills toward Broken Bow. Hail in this size range can cause serious damage to vehicles, and given the rural character of much of this region, people are sometimes caught outdoors or on the road when these cells develop faster than expected. Through the 5 to 7 in the evening window, the storm line will be expanding and likely beginning to organize more linearly as storms interact with each other and with outflow boundaries produced by earlier cells. This is a very common sequence in Great Plains severe weather, where you get that initial afternoon period of potentially discrete supercells, followed by a gradual upscaling into a more linear system as the evening progresses. The tornado threat, if it exists at all Saturday, will be highest during the discrete supercell phase in the mid-afternoon hours before that upscaling begins. Once storms transition into a squall line or bow echo configuration, the tornado threat decreases but the damaging wind threat actually increases because organized linear systems can produce what meteorologists call a bow echo, a curved section of the line that acts like a giant piston, pushing damaging winds well ahead of the storm. Wind gusts to 60 or 70 miles per hour with a bowing line segment are entirely plausible across western Nebraska and into the Dakotas during the Saturday evening hours. By about 8 to 9 in the evening, the leading edge of the storm complex will be pushing northeast and east across central Nebraska, with the heaviest activity beginning to thin as the system moves into areas with weaker atmospheric support. Rapid City, South Dakota will be watching for gusty winds and possible hail through the early evening hours before activity gradually diminishes after dark. Pierre and Bismarck may see some residual convective activity well into the overnight hours, but severe potential with that activity should be low. Meanwhile, during the afternoon and evening on Saturday, across the southern portion of the Dryline from central Kansas, down through the Texas Panhandle, and into West Texas, there remains a conditional but real risk of isolated severe thunderstorms. The Storm Prediction Center noted that despite weak forcing along the southern Dryline, strong surface heating will leave the atmosphere uncapped, meaning storms can develop with relatively little trigger. A supercell or two in the Texas Panhandle during the Saturday afternoon hours is possible, and any supercell that does manage to get organized in that environment will have access to enough mid-level shear to produce large hail and a brief tornado. Amarillo and Lubbock should stay weather-aware through Saturday afternoon and not dismiss the threat just because the risk areas are focused further north. Now let us talk about the flooding picture, because across the southeast and deep south, rainfall is going to be the dominant story for the next week, and the cumulative totals being forecast are significant enough that localized flash flooding is going to be a genuine concern for multiple areas. The Omega block pattern has been funneling an atmospheric river of moisture out of the Pacific and through the Gulf of Mexico, and this moisture channel has been feeding persistent showers and thunderstorms across the southeast for the better part of the past week. The Weather Prediction Center is signaling continued widespread rainfall across the deep south and southeast through at least early June, with the heaviest totals expected in the corridor from East Texas through Louisiana, Mississippi, Alabama, and into Georgia. For the period between now and June 5th, rainfall totals across the Gulf Coast are expected to be substantial. The Baton Rouge and New Orleans areas, along with communities along the Louisiana Gulf Coast including Houma, are looking at the possibility of 4 to 7 inches of total rainfall accumulation. Memphis and the mid-Mississippi Valley region can expect 2 to 4 inches. Atlanta and Birmingham are likely to see between 1 and 3 inches over this same period. These numbers would be manageable under normal circumstances, but the problem in much of the Deep South and Dixie Alley right now is that soils are already heavily saturated from repeated rounds of heavy rainfall over the past several weeks. When you pour additional rain onto saturated soils at a high rate, water cannot infiltrate into the ground. It runs off immediately into drainage channels, creeks, and low-lying areas. Flash flooding can occur with rainfall totals that would be harmless if the ground were dry. The National Weather Service has emphasized this concern in recent forecast discussions, noting that the risk of localized flash flooding is going to remain elevated across much of the southeast for the foreseeable future, not because any single storm event will be record-breaking, but because the cumulative impact of repeated convective rainfall on soils that have no capacity left to absorb additional water creates a hair-trigger flooding environment. If you live anywhere from Houston eastward through the Gulf Coast states and up into Alabama, Georgia, and the Carolinas, do not dismiss a flash flood watch or warning, even if the rainfall total forecast sounds modest. In a saturated environment, 2 inches of rain in an hour can overwhelm drainage systems and flood roadways that might handle that same amount without incident in a drier pattern. There is also at least a low-end chance of a tropical system trying to develop in the Gulf of Mexico or near the Florida Peninsula sometime around the transition from May into June. Both the GFS and European models have been flagging this possibility in ensemble guidance over the past several days. The National Hurricane Center has not designated a formal development area as of this forecast, which is the appropriate standard to reference, but the pattern of persistent warm Gulf waters, a nearby moisture plume, and a favourable upper-level environment around the periphery of the Omega Block does create at least the low-end background conditions for tropical development. Even if something were to form, forecasters are not anticipating an organised tropical storm of significant strength. What it would likely mean for affected areas, primarily Florida, and possibly the central Gulf Coast, is additional heavy rainfall and gusty winds on top of an already very wet pattern. More rain for a region that is already dealing with saturated soils and localized flooding is the primary concern regardless of whether formal tropical development occurs. Now, let us look at the extended period, which takes us from roughly the 3rd of June through the second week of the month, because this is where the atmospheric story gets more genuinely interesting for the severe weather community. The Omega Block is going to erode. The timing is still somewhat uncertain, and that uncertainty is meaningful, but the current model consensus suggests the ridge begins to break down in earnest somewhere between the 4th and 7th of June. The mechanism is the eastward progression of that ridge we talked about earlier, combined with the gradual weakening of the blocking low-pressure system that has been sitting off the west coast. As the west coast low weakens and the ridge slides east, the jet stream should begin to re-establish a more amplified but mobile trough pattern across the Rockies. When troughs begin ejecting over the Rockies in a pattern like this, they carry upper-level energy and wind shear into the central plains, and when that happens during a time when Gulf moisture is already streaming northward, you get the classic ingredients for organised severe weather outbreaks. The European model, which has generally performed well with pattern recognition at extended range this season, is indicating that the second week of June, specifically around June 9th through the 12th, could see a significant pattern change that would bring an organised severe weather window to the central plains, potentially including Nebraska, Kansas, Oklahoma, and the Texas Panhandle. The GFS is somewhat more hesitant and places this window a few days later. Neither model has the kind of run-to-run consistency at 10+ days that would allow a specific date to be highlighted with confidence, but both are at least in agreement on the general concept, which is that the current blocked, quiet pattern for severe weather is not going to last. Something is coming. The models just disagree on exactly when. What to watch for as we move through this week is the evolution of the shortwave trough, currently sitting across the northern Rockies, and whether it can act as an early trigger for severe weather across the northern plains around Monday and Tuesday. The Storm Prediction Center's day 4 through 8. Discussion notes that isolated severe storms may fire on Monday afternoon over parts of the north-central United States near low-level convergence boundaries, in spite of limited forcing. This is the mesoscale severe weather character that has dominated the pattern all month. Small scale, hard to predict more than 24 hours in advance, but real and capable of producing significant impacts. The Climate Prediction Center's probabilistic hazards outlook is also noting that by the period from June 6th through 12th, there is a growing signal for a ridge amplifying across the central United States with positive height anomalies that could reach more than 3 standard deviations above normal. When that happens, the atmosphere has essentially built up an enormous amount of compressed energy, and when the ridge eventually breaks, the severe weather response can be rapid and intense. That is the scenario forecasters are watching most carefully right now for the second week of June. The June 2026 severe weather outlook, updated at the end of April, has already flagged the Central Plains corridor covering the Dakotas southward through Nebraska, Kansas, and into Oklahoma and northern Texas as a zone expected to see above normal severe weather activity for the month overall. That climatological signal is consistent with what the models are now beginning to show for mid-month. So here is the framework for the next 2 weeks in simple terms. Right now, we are in the final stages of an omega block pattern that has kept major severe weather outbreaks at bay through most of late May. The next several days will feature mesoscale severe weather, which means unpredictable, isolated, hard to pin down but capable of producing damaging hail, destructive winds, and low-end tornado threats across the plains and southeast. That mesoscale character peaks this Saturday afternoon across western Nebraska and southwestern South Dakota, with a conditional tornado threat during the discrete supercell phase in the mid-afternoon hours. Meanwhile, the northeast deals with an unusual late May cold snap and mountain snow across the White Mountains and western Maine tonight through Saturday morning. And then, beginning around June 4th and accelerating toward the second week of the month, the pattern shifts. The omega block erodes, the jet stream reloads, and the Central Plains enters what could be a much more active and organized severe weather window. Guys, I genuinely cannot remember the last time I covered this many distinct storylines inside a single late May weather pattern. Snow in New England, severe thunderstorms in Nebraska and South Dakota, persistent flooding rains along the Gulf Coast, a potential tropical signal near Florida, and a brewing pattern change for early June that could bring the plains back into full outbreak mode. The atmosphere is doing a lot right now, and that means every single one of you, regardless of where you live, has something worth staying alert for over the next 7 to 10 days. Make sure you are subscribed so you do not miss the next update, because this pattern is going to keep moving and the details are going to keep evolving. We will have another video up as soon as the forecast warrants it, which at this pace likely means within the next day or two. And as always, the one thing I want to leave you with is this. The omega block does not mean the severe weather season is over, it means the atmosphere is reloading. What comes after the block breaks is the conversation that every serious severe weather watcher should be having right now. Because when the plains reloads in early June after a compressed blocked pattern like this, the instability and moisture that have been building underneath the ridge do not just disappear, they become fuel. And fuel, when a trough finally comes through to ignite it, is exactly what produces the kind of severe weather outbreaks that make an entire season memorable.